Okay, so let's look at functions. Okay, this is something that we're actually very familiar with. For example, we can have a function like f of x equals x squared. Okay, and we know what that means, right? We have different representations for functions. In fact, when you look at f of x equals x squared, you might immediately think of something like this, right? Yeah, it's supposed to be symmetrical. Sorry about that, but we recognize this as a function, right? We would also recognize, for example, this as a function, right? And we would recognize this as a function, and so on. So, graphical representations are very common ways of doing functions. Another way to do a function is as a table. So, for example, we could have x and f of x, and I could say 1, and that is 1, 2, 4, 3, 9, 4, 16, and so on, right? And again, we would recognize that as a function. Okay. Now, what do all these have in common? Um, well, you may remember back from probably middle school, maybe a little earlier, that you talked about what was known as the vertical line test, right? So if we draw a vertical line here, we draw a vertical line anywhere on this graph, right? We only ever intersect the function in one place. Okay, so that's the vertical line test. Okay, this is true for all of these, right? Okay. Something else that you'll immediately recognize is that over here, right, there's only one row for any given x. Okay, so you see here's the entry for 1. We do not see 1 over here, right? That's not allowed. Okay, so that's actually related to the vertical line test. There's only one y value for each x. And this follows from this because we have a rule to compute the value of the function. So once you know the value of x, then that tells you what f of x is. There are no other possibilities. Okay, so that's what a function is. Now, I want to make a kind of an important point here, which I think follows directly from this particular representation, and that is that this is a relation. Okay. Remember that when we started with relations, we actually represented them as tables, and we said, you had a row for each, entry in the relation, and the entries in the relation were pairs, and the first element of the pair came from some set, and the second one came from some other set, right, or maybe even the same set. But the point is that you had a relation which is a subset of the cross product of two sets, and we can write it as a table, and that's exactly what we're doing with functions, right? So we have a relation, but we have this extra condition. There can only be one entry associated with each element of the first set, right? So that's really what a function is. And what I want to do now is turn that into mathematics, okay?